Hi everyone, I'm Devanshi. In this video, I'm gonna talk about the assignment 2, which is the VPN. So for this assignment, we created the topology according to the requirement given, and for that we took the two servers, these two servers, 4 pieces and 3 routers. So in this router we took in these 3 routers we took the additional one module as the NM4E. We can see here also we took this additional module NM4E. We took this additional module to connect to all the interfaces. After that, why we configure the VPN here? The basic reason behind configuring the VPN is to secure the connections over the public network. So in this assignment, we built the topology and did the configuration to meet the given requirements. We can see all the requirements were given here. All the requirements were given here, so we follow all these requirements. We created the topology so that we can meet these requirements. So in this we can show that what we need to do. So the basic requirements were that the HQ staff, this PC, you can see the HQ staff can access the server at the HQ site, I mean this server, and to the internet server. And same goes with the staff PC at the branch side also. So this staff PC B staff can access the server at the HQ side and can access the internet server also. But there is different scenario with the guest PCs at both the sites, headquarters and branch. So this was that the guest PC at both the sites should access only to the internet and not to the server at the HQ site. So this PC can access, these both pieces, HQ guest and B guest can access the server, internet server only, but not to this server that is located at the headquarters site. So for that we first did the static and default routing. We can see here also we did the static routing on this ISP router and we did the default routing on these both routers. We did the static and default routing to check the initial configuration. If we don't do the static and default routing on these routers, the initial connectivity cannot be established between all the PCs and servers. You can see here, like I did the default routing on this branch router, and same we did in the headquarters router also, and in ISP router I did the default routing. So we did this to achieve the connection at the first stage between all the servers and the PCs. So the connection was successful after doing that. So after that we created the extended ACLs on both the routers. So you can see here, this is like I first gave the initial configuration. I gave the IP address and all that to all the interfaces and all that. So after that we here on branch routers we created the extended access list. So I permit some IPs here according to the requirement which were given already in the requirement document. So after creating the ACLs, we created the NAT pool. So you can see here I created the NAT pool. So the main a point in creating the NAT pool is that it is given in the requirement document to create the NAT pool according to your credentials. So there is only one thing that you have to remember when creating the NAT pool and ACLs, that the naming convention should be the same. If the naming convention should not be the same, you will not get the results at the end of your this assignment. So after creating the NAT pool, we created different policies, and those policies can help in the security purposes. So we created some policies that will help in the security purposes. Like we created here on up, you will see that I created this we created one this cryptographic key. So for that I use like this key, secret 55. So and this will address to the this headquarters outer interface .20 183.20. So Here we run all the commands that executed cryptography and crypto map. You can see here I executed all these commands. So here I first executed this command crypto ISA KMP policy 100. So it's 100 is nothing, it's just one number that we took as a reference with the policy. So this ISA KMP, it is like Internet Security Association and Key Management Protocol. What can we do with this protocol? This protocol provides a framework for the IKE protocol, right? So we if we are configuring the cryptography and all the crypto maps with the IKE protocol, and this ISA KMP protocol provides the framework to the IKE protocol. Then we did the crypto map here. You can see we did the crypto map here. Why we are doing the crypto map here? We did the crypto map because it is used to configure the software with the software which we used, and basically in other language you can say that it is used to configure the interfaces. So on all the interfaces that are connected to the routers, we give the you can see here on all the interfaces we give the IPNet outside and the crypto map commands. So this crypto map is used for that purpose. Other than that, we use this command set peer. Set peer is used to like specifies the IPsec peer in the crypto map. So we set peer we use this IP. So this is the headquarters external interface IP, right? Then we use the command here as match address. This command basically specifies the ACLs that we created for the crypto map entry. So if we don't use the match address command, then all the ACLs we created before doing that will all be wasted. We cannot execute all those ACLs without using this match address command. After that, we use this command transform set. We use this command because this command specifies which transform set is used with the crypto map entry. So here you can see we used this transform set, right, this entry, and you can see in match address also we use this entry. So these all are directly related to the ACLs we created before doing all these things, right? So here we did all these all the commands we run. So we run all the same commands on the headquarters site also. So you can see here after running these all the crypto commands, I assigned the where is that? Yeah, here. So I assigned all the IPs to all the all the interfaces, and run these IPNet inside, and which the specific command that is to the specific interface, right? So when we did that, after that we can verify that after doing all the configuration we met our final result or not. So we will see from here. So it was written that HQ staff can access to the int server and the HQ server. So we will see here, we will open the HQ staff and we will open the web browser. For that we will enter the URL IP of the HQ server 172.20.180.11. you can see that we are it is giving us the correct result. Then we will see that whether you can access the int server or not, right? So we will enter the IP of the int server. It's 172.20.187.90. Go. It's better like if you check after closing this, because sometimes it shows us the previous results. So we will check the int server again, 172.20.187.90. so it is giving us the correct result. Then we will check with the B staff whether it is accessing both the servers or not. We will enter the IP of the HQ server 172.20.187.90. 180.11. It is giving us the correct result. Then we will try to access the int server again with the b staff 172.20.187.90. So we are able to access that also. Then we will check from the guest servers. So in guest server we will enter the IP of the internet first, because it is given in the requirement that it should access the internet, right? 172.20.187.90. so it is accessing that. Now we will check that whether it's accessing the HQ server or not. Ideally it should not access the HQ server. We will see 180.11. okay. If it is taking so much of time, I'm sure it will give us some error, and what we want that also. So it gives us the request timeout error. We want that only because it is given in the requirement that it should not access the HQ server, right? So now we will check with the guest PC at the branch side. So it should access the internet server 172.20.187.90. so it is giving us the correct result. Then we will check for the HQ server also. So it is 172.20.180.11. so it should not access that. It will give, sometimes it took some time, yeah. So it gave us the request timeout. So it means that this host is not reachable, right? So we can check this from here also. If you try to access the B staff also, it will not allow that. 185.11. You can see it is giving us the host unreachable, and that's what we want, because it is given in the requirement that it should not access either to the HQ server and not either to the internal networks also. So it is not connecting to the internal network also. So after that we met our requirements, and at last we can check that whether we run all the cryptographic commands, whether all the crypto map entries are set or not. We can check here. So in the headquarters, so we will enter the command here, show IPNAT translations, and you can see that all the NAT we configured are coming here, right? We configured these NATs and these are coming here. So we configured the NAT properly. We will see in the branch router also that whether the NATs are configured properly or not. So you can see show IPNAT translations. So you can see that all the IPNATs are configured here properly, right? What we configured, it is coming properly. After that we will see all the cryptographic commands, whether they have configured properly or not. So we will run the command like show crypto IPsec SA. So you can see that it is giving us the error, giving us the result. It is giving us the result that packets encapsulated. So at the headquarters side the packets will encapsulate, and at the branch side the packets will decapsulate, right? So we will check here that whether packets are decapsulating here or not. So run the same command here, show crypto IPsec SA. So you can see here that all the 12 packets were encrypted there, and all the 12 packets are decrypted here. So it means we are doing good. We configured the ISA-KMP. We configured that ISA-KMP to which provides a framework for the IKE protocol. So we will check whether the state of ISA-KMP, what is the state of the ISA-KMP, and to verify whether that is configured or not. So if we want to configure that, we will run the command show crypto show crypto ISA KMPSA. So you can see here it is giving us the correct result, and it is showing the active also. So we are uh, decaps we are sending the packet from here, right? So it is showing us the correct IP 184.20, which is the IP of the branch. It is displaying us the correct IP, right? And source is 183.20, which is our source. So it is displaying the correct source and destination IP, and the state is also active. It means this is configured properly, and the state is also correct here. And we will check at the branch router also, same. So show crypto ISA KMPSA. So you can see here that source is 184.20 because the source is this one, the branch IP, and the destination is 183, which is the headquarters external IP, and status is active here. So which is good, and that what we wanted. So this is all what was in assignment 2, and with that we configured everything about the VPN. There was just simple one rule for the all the configuration. We just did the static and dynamic routing first. After that we created the ACLs. After that we created the NAT pool. Then we run all the commands for the cryptography. Then we configured all those commands on the interfaces of the routers. So that's what I was telling you in this assignment 2. Thank you.